This is part 2 video of the Python data capstone project for 911 calls. If you haven't already watched part 1, I recommend you first watch that video, as this is an extension of where we let off of that video. That video has been linked in the description and comment box, and after you have watched that, you can come back to this one. In part 1 video, we imported the libraries and the CSV file, checked the info and head of the data frame, then did some basic analysis regarding most frequent zip codes and townships, where the 911 calls were made from, what were the reasons for the call, and the calls made per day and per month based on different reasons. Now we will continue from where we left off. So here at the end of the last video, we noticed that the monthly data for each of the regions EMS file and traffic was going down in August and December, and we had missing data for September, October and November. So here we have to create a group by object called by month, where you group the data frame by the month column and use the count method for aggregation. So what we will do is name this object by month and use group by the month data, and we will use count aggregation. So let's see what this produces. So here we have grouped the data by the month column. So for each row for any given month, we have one added to this individual columns. Now if you see here, just for the first month, you will see we have different data for uh, zip and township and address compared to the other columns. And if you go back to the info of the data frame, we check at the start of this project, we had some null values for the zip column and for township and for address columns. So for further analysis, we will ignore those columns. So what we have to do now is to create a simple plot of the data frame indicating the count of calls per month. So here we are looking for this count of calls per month. What we could do is take the data frame, use the plot method, and here if you check the signature, we have to pass in the data, and then we have options for data on the x-axis and y-axis, and we have a kind parameter as well, and by default that is given as line, so we don't need to specify that. But in place of line graph, if you want to plot bar graph or histogram or box plot, then you can select this different kinds here. So for first one, the kind is line. This is given by default, so you don't necessarily need to select this. Now for x, if you don't define anything, it will automatically take the data from the index. So we will let it be, and we will use for y, we will use this e column here, which was given as dummy column, which data in each row as 1. So the count should be perfect for each of the added up rows. Apart from e, you can also use any of the columns here except this zip, township and address, as those columns had some null values. So let's plot this. So we made the mistake, we passed this in on the df data frame where the value of e was 1 for each row. What we need to do is pass in to this new data frame we have created by month. And now to remove this legend, you can pass in the legend parameter as false, and we will also restrict our xlim just to 12, just for the aesthetic purpose. So here the plot matches to the given plot. If you want to remove this text, you can pass in a semicolon at the end of the code. Now what we see here, that the number of calls based on this monthly comes down from January, then it goes up during the summer months, and then falls up drastically for the October and December data. And this also produces an estimate for the number of calls for the missing months. Now see if you can use Seaborn's LM plot to create a linear fit on the number of calls per month. We will use regression to get an estimate of the calls in those missing months. Keep in mind you may need to reset the index to a column. Okay, so for the LM plot, we need to pass in both the x parameter and the y parameter. So what we will do here is use this by month data. Actually, for LM plot, we have to do sns.lm plot, pass in the data as a parameter. But before that, we will reset the index by month, reset index, and what this will do is it will convert the index into a column, and we will do this in place. Let's check this, and now that monthly index has become a column here. So for this LM plot, we will do data is equal to by month data frame. Now this month here is a column. We'll take that on x-axis. On y-axis, we will use our E column, and let's pass this. Now we will make some further adjustments here. If you check the LM plot signature, you have an height and aspect given here. So this overrides the original figure size which we have defined globally as 4.5 and 3.5 pixels. So this by default is giving you a 5 by 5 picture, 5 by 5 graph. We can change this to, let's say, 4. Now it will give a smaller visualization. We also want to decrease the size of the scatter plots in the line. For that, you can pass in scatter keywords, pass this as a dictionary, and for the size we have the s parameter there in the scatter plot, and we let's go with 10 and see what that produces. So it's small enough now. Then to change the width of the line, we can pass in the line keywords. Once again we will pass it as a dictionary, and we have the line lw parameter for line width there, and let's go with 1. It is too thin, so let's try 2, and now it looks okay. So here this graph has produced a fit, and this shadow here is the error. So what we see as we go from January to December, the regression analysis is showing that the number of calls per month goes lower and lower. However, if you see the actual scatter points here, it goes down and then goes back up again before it crashes in August and December. And that's why it is showing a much larger margin of error here with this shadow portion. So the actual data points could lie anywhere from 9,000 to 12,000 for this month 10, that is October. So it doesn't give a very good fit here because of this high error. Now create a new column called date that contains the date from the timestamp column. You will need to use the apply along with .date method. So what we will do is call the date column as if it already exists. We will use the timestamp data, and here if I show you what does if we take a look at our time object again, remember it was the first row from the timestamp column. If you call this date method here, it will return you a timestamp date of timestamp object. If you actually call this, it will return just a date time object which contains just the year, month, and day, not the time data. Similarly, we can call in a time method as well, and that will return the actual time, that is hour and minutes. So what we could do here is use this apply method with lambda expression, and for data in each row, what we have to do is use a date method, and that will pull just the date information to this new column. Now let's check the head of the data frame, and here you can see in the last column we have created a new column called date, which has just the date information. If you want to check the data type of that column, it is an object, and it is a date time object. Now group by this date column with the count aggregate and create a plot of counts of 911 calls. So here we have to create a plot like this by grouping the date column. Group by date and take the total count. So in this data frame we have a total of 259 rows. Let's check the head of this data frame. Now here all of the data has been clubbed or grouped by individual dates, and we have the data here for we have the total count here for each of the columns. Now remember, zip, township and address had some null values, so we will ignore those and use other columns for our visualization. So to create this graph, we will use this by date object. Plot kind is line graph, and for y we will use the e column. So here we can hardly read the data on the x-axis, so we can increase the width of this figure using the fixed size parameter, and we will also remove this legend. We don't really need that here. So as you can see here, oh, just notice that this December data is from 2015. The data starts actually from December 2015, then it goes to January 2016, Feb, March, April, May, June, July, August, and ends in September of 2016. Actually, it ends in August itself, just before it reaches September. So rather than what we were thinking is we have missing data from August till December for the year 2016, the data itself starts from somewhere in December 2015 and continues only till August 2016. And that's why we were getting the total count of the calls were getting dropped for December and August, because I think the data is not for complete December. In fact, if you check here, the first date, the head of the data frame showed it was 2015 December 10th. Now let's quickly check the tail as well. Yes, see, so the data starts from 2015 December 10th and it ends on 2016 August 24. So we have data missing from August 25th, 26th and onward, and we don't have any data before 10th of December in 2015 as well. That's why the total number of total counts of call is less in August and December, because we don't have the data for the complete months. If you analyze just this data, this is the total call by date. On any individual day, it looks like the total number of call varies between 300 and maybe 420, with spikes on certain days. On this particular date, there were more than 900 calls, and then this was in January. Then in Feb, on this day, there were about 600, little less than 700 calls. On this day in April, there was about 600 calls, again 600 calls in July as well. And there were some days where there were very little call, like on this day. We can't really read much on at the start and the end because we don't know the time of those data. But on this day, there was a spike on the downward direction. This is at the end of the April, where there were less than 200 calls. It looks like there were only 150 calls on that particular day. Now we'll do one thing. We will recreate this plot, but for different reasons given for the 911 call. Remember, those were EMS, traffic and fire. So what we could do is, we could filter the data frame for individual reason and then plot this graph. So we will start with filtering this for traffic. And now we will use our group by, which we did here by date. On these reasons. And then we can plot our graph on this data frame. Let's check this data frame first. So here, as you see, we have the same data frame by date, but the number of count is lesser as we have filtered the data frame for just the traffic reason. So we can plot on this data frame. And we can also pass in the title parameter here to give a title to this graph by the reason. And if you want to remove this text from here, you can pass in a semicolon. So if you see this graph just for the traffic reason, the data, that is the number of calls each day, is varying between 80 and 200 with spikes on certain days. Now next we have to do that for fire. Filter it for fire, then group by date dot count. Let's check the head of this data frame. Now we will plot here and we'll pass in a title as well for fire. Here if you see this graph, the pattern matches with the given graph here for fire. It looks like the number of calls varied between 40 and 80 per day with spikes on certain days. Next we will do the same thing for EMS as well. Group by date, use count aggregation, and let's just check the head of this data frame. Now plot the graph here. And the title for this would be EMS. And here it looks like the calls on each day were between 150 and 225 with spikes on downward direction on at the end of April or the first day of May. And we see that here as well the counts are mostly between 150 and 225. Now let's move on to creating heat maps with Seaborn and our data. We will first need to restructure that data frame so that the columns become the hours and the index become the day of the week. So we need the day of the week on the index and hours on the columns. So we basically need to create a matrix data set. So there are a lot of ways to do this, but I would recommend trying to combine group by with an unstack method. So the easiest way to do this is actually using the pivot table. If you check our data frame again, this is our original data frame. We have added this new columns: reason, hour, month, day of week and date. Now what we want here is this day of week to be our index and this hour column to actually be columns. So this R varies from 0 to 24, 0 to 23 rather, right? So we want 24 columns for each hour of the day and we want 7 rows for each day of the week. The easiest way to do this is use the pivot table. If you check the table, we need to pass in the values, the index and column. So here for index, we can use day of week. For columns, we can use our hour column, and we need to use pass in some values for the matrix. We can use the E column, which is basically one for everything. And now there's another parameter here which is called aggregate function. So what this produces is the aggregate on that data we are clubbing. So by default it is given as mean. We should use sum here because we want the count of each row. If you just use mean, it will produce 1 for all the cells by default C. So what we will do here is use this aggregate function, use this aggregate function and pass in sum. This is numpy sum function. So it will do sum of all the rows and we have our data in a matrix format. Now this is the easiest way of doing it. What this question asks here is to try the group by method with unstack method. So I will show you how to use the Groupby Unstack to produce the same data frame. Here what we will do is use the group by method, and rather than grouping by one column, we will group it. We will pass in a list of two columns to group it by, and that will produce a multi-index data frame. So we will use our day of week and R. Let's see what this produces. We need to pass in an aggregate function. So we will use the count method, and what it produces is, you can see we have two index here. One is day of the week, and then we have the R for each day of the week. Now if you use the unstack method on this, so what this unstack will do is, it will take this second index. So remember, the index of the multi-index would be 0 and 1 if you go back. So the day of the week would be 0 and R would be 1. So here for unstack, which of these index do you want to come at the column? So which level of this multi-index do you want to appear in the column is based on this level parameter. So if you pass 0, the day of the week will come in the columns and the R will remain in the index. So let's check this. So we have R data on the row index, and the day of the week has come in the column. If you pass in 1, it will be the reverse of this. It will be our day data here and R data here in the column. By default it is given as -1, which means it starts at the end of the last level of the multi-index automatically. So that will be our R data. And now let's see, we only want, so what's happening here is we have this data for all of these. If you go back, so we have all of these columns here. We want this data only for one column, so we will select our E column and then use the unstack method. By default the level is going to be -1, so it will convert this R index into the column. So now this is a 7 by 24 data frame. We have 7 days of the week and 24 hours ranging from 0 to 23 column, and we have the sum, that is the count for each row, which has E value as 1. Now let's give this data frame a name. Next we have to create a heat map using this new data frame. So for that we will use the cbound heat map method. Pass in your data, and then we will pass in the cmap parameter. This semicolon will again remove this text from here. We want to increase the size, and unfortunately for heat map we do not have a fixed size argument or parameter given to adjust the size, so we can pass in the matplotlib parameter. plt.figure, use fixed size parameter, and we will pass in 9 by 5 here to increase the size of this figure. Now here, as you see in this color bar, the darker color has lower value and the lighter color has higher value, which is not very intuitive. So I am going to reverse the color here, use _R at the end of the palette here, run this, and now the lower values have lighter color, and this yellow turns into green, which is darker for higher values, and if you go even higher, the colors become darker and darker. This is intuitively much more easier to understand. And this is now visual representation of what we have done above. We have the days of the week on the y-axis, and we have the hour data on the x-axis. So here what you can see is on the night time, that is midnight, then 1 a.m., 2, 3, 4, 5. This has yellow and green color, which is at lower value. And then as you go through the day from the morning to the afternoon, late afternoon and evening, the colors become darker and darker as you go through the day, and then start getting lighter again as you reach 9 p.m., 10 p.m. and 11 p.m. Similarly, if you look at the y-axis, the day of the week, it has the lighter data on the weekends, Sunday and Saturday, compared to the other days, Monday, Friday, Tuesday, Thursday, and Wednesday. Even during the hours on which there are more data, this has lesser data on weekends than compared to weekdays. And so we can infer two things here. One is the number of calls increase as you go through the day, and most of the calls happen around this time from 3 to 7 in the evening. And similarly, most of the calls happen on the weekdays. There are more calls happening on the weekdays than on the weekends. Now let's create a cluster map for this. The size is too big, so we will make this smaller so we can read this. Here under the cluster map, if you check the signature, we have a parameter given for figure size. By default, it is given 10 by 10. We'll make this 6 by 6. So here we have used redis underscore r, so it has reversed the color map so that lighter color has lower value and darker color has higher value. And here all of the hours and days have been clubbed together to show all of the higher calls together and all of the lower calls together. So once again, it makes sense that lowest number of calls comes late at night from midnight till early morning, as most people are sleeping at that time, and most of the calls come from late afternoon, late in the daytime. So early morning from 9, 10, 11, 12 till you see 4 and 5 in the evening, and then it starts dozing off as you go later and later in the day. The peak data is during 4 and 5 in the evening. And similarly for the weekends, as you see for Saturday and Sunday, those are clubbed together at the bottom of the cluster map, and all of the weekdays which has more calls coming in are clustered together as well. Now repeat the same plots and operations for data frame that shows month as the column. So here we had the weekday. So actually here we had our hour data on the columns, and now they want to see month on the column. Now we want to see month on the column. So what we could do here is create a data frame which says by day, month. So here we can copy this code and change the hour to month data. And this data matches here with what is given. In the notebook, we have our days on the row index and months on the column, and we have total number of calls, as this data frame is given as a matrix where the actual data in the cell relates to the column and uh, row index. So we will create a heat map using this. So here for data, we will pass our new data frame, which is by day, month. So here we have our day data on the row index and our monthly data on the column index. And if you remember, while analyzing earlier, we realized that the data actually starts from December of 2015. To be precise, it started on 10th of December of 2015 and went till 24th of August of 2016. So we had incomplete data for this December and for October months. And so obviously the number of calls were lesser compared to other months. So these two are clubbed together. The other months are clubbed together, but you don't see any specific pattern here. Once again, the Saturday and Sunday are little lighter compared to the other days. So clearly, in terms of days of the week, we see that there are more calls coming in on the weekdays than compared to the weekends. But you don't see anything based on month. Let's check this for cluster map as well. Here, so if you see on the y-axis, once again the weekends have been clubbed together and weekdays have been clubbed together, and once again the August and December months are clubbed together, and rest of the months are clubbed together. So in this project, we found that more calls are made on weekdays than weekends, and also more during late afternoon and evening hours than compared to late nights and morning hours. That kind of makes sense, as people are most active during those time frames, so there would be more traffic calls and maybe even EMS calls. However, there was no pattern observed for the month's data, partly due to missing data for the fall and winter months. If we find the missing data, then it could be analyzed for different reasons for summer and winter months, as there could be more fire incidents in the summer months and more traffic related calls in winter months. So that's all for this project. If you want, you can continue exploring this data further, but for now, thanks for watching.